Hello, I am Tyler Disney, and in this tutorial I am going to be demonstrating how to design and model duct systems in Revit MEP 2013. So there are two main categories of going about designing airside systems in Revit. There is the way that is quick and you don't have to think about it too much and you just draw duct and equipment and stuff. And your result is a 3D model and nothing more. And the other way is to put in a little bit more effort in the beginning and set things up a little bit better. And the final product is a information model that allows you to do a lot of analysis and have a much better understanding for what's going on in your design model, and really have more of a design model than just a physical model. So there are a multitude of benefits to doing it the right way. It kind of goes on and saves you a lot of time and reduces errors. I'm a real big believer in doing things the right way from the start. I've never done a project, looked back on it, a project that I'd hacked together, looked back on it and said, yeah, I'm glad I hacked that together. So I'm going to try to pass on what I've learned about making systems right the first time. So let's hop into it. I'm going to open up a working view. Never mind that. I don't have anything linked into this, so you're just going to have to use your imagination. Step number one is lay out the equipment first. So that means diffusers, the terminal equipment, diffusers. Then it means any other equipment such as VAV boxes, air handlers, anything else that's in the duct stream. So we're going to start with the diffusers. So I'm going to go find my air terminal. And I'm going to put 3 over here, and I'm going to put 3 over here. Just going to kind of assume there's a room over here, say, and there's a room over here. Like I said, you'll have to use your imagination, but that's fine. Okay, so those are laid out. That's great. And now I need to lay out my VAV box. That's on mechanical equipment. And I'm going to have one to control this room, and I'm going to have one to control this room. So get it oriented the right way by pressing Tab. Place those two. Okay, great. And I'm also going to need an air handler. Not that one. Okay, great. Air handler, VAV boxes, air terminals. And now I've just made the classic rookie mistake of placing everything at 0 inches from level 1. So I'm going to put my air terminals at 10 foot. Oops, and I accidentally hit F1. I hate that. I'm going to place my air terminals at 12 foot. And my air handler is going to go somewhere on the roof, 20 foot. Whoops. I'm just going to adjust my view range up to 30 feet so I can see everything. Okay. Okay, so I have my equipment. That is step one. And the second thing I need to do is not model the duct. The second thing I need to do is set up my systems, the information systems that define the relationships between these, because we know that these three air terminals are connected to this VAV box, and these two VAV boxes are connected to this air handler. But Revit doesn't know that, so we need to explicitly tell it. So the way to do that is to select the air terminal, and then up here in the ribbon click duct under create systems. And it's a good idea to give it some intelligent name. So I'm going to say it, I'm going to call it right room supply. And then I'm going to hit edit system, and add to system is checked here. And so from here I'm going to add other elements, other air terminals. Now while I have this selected, add to system, I'm not going to click on the VAV box. The VAV box is what's supplying the air terminals. So the way Revit thinks about it is that the VAV box is the piece of equipment. And right here is the button Select Equipment. So hit Select Equipment and click on the VAV box. And that establishes the relationship between the VAV box and the diffusers. Okay, so we're done with this system. Hit OK. And now nothing has obviously changed, but if you mouse over one of these elements and hit the Tab key, dashed boxes will show up, and they're showing, hey, this system, it has these elements, and then it draws a box over the entire system. Cool. So I'm just going to do the same thing for the system over here. Left room supply. And I'm just going to test it. It should always be alt-tabbing stuff. It's a very powerful and useful command in Revit. Okay, so I've done that, and really what I should have done before I even did that is to activate my system browser. So I'm going to open that now, which is in View, User Interface, and then System Browser right here, it's unchecked. Go ahead and check that, and then the System Browser will show up. And this is a list showing all of the systems, and we've got some unassigned systems. Okay, so the piping systems are coming from the air handler. We'll ignore those for now. Ideally, you don't want any unassigned systems in your model. Unassigned systems are a sign that you're not taking very good care of the equipment that you have. A few might be excusable, especially while you're working in it, but you definitely don't. You definitely want things assigned to specific systems. So we can see that we have these two systems here defined. I'm just going to open these up so you can see everything. So here's the right room supply, and see that it's highlighting it as I'm selecting it here. Here's the left room supply, and you can see the relationship. Here's the piece of equipment, and again it highlights it. Here's the system, and then here are each of the elements that compose the system. So it's a very nice and neat way of showing things, and it's also showing that there's flow associated, and some other parameters. If we had spaces set up, it would tell you what space that's in, and that's going to be really useful later too. But we'll just collapse that a bit and keep that there. Okay, so we have this system defined and we have this system defined. But now what about the system between the VAV boxes and the air handler? Well, this is just one up in the hierarchy of systems, if you will. And so what's going to happen is these VAV boxes are going to sort of take on the same behavior as the air terminals that we just did, and then the air handler will become the equipment. So to set that up, select one of the VAV boxes, go to Create Systems, and we're going to call this HU1, say, Supply. Great. And now we're going to edit the system, add to it. We're going to select the other VAV box, and so there's two air connectors on this VAV box, and that's what is telling Revit that it can be part of a duct system. So we want to select the right one, and the one we want is the round one, because that's the inlet, and that's what's being fed from the air handler. Okay, and then the equipment is the air handler. So I have a number of supply connections on this because it's a sort of generic component that I created, and I created a couple of connectors based on which configuration I was going to use it in. So 77 by 34 connector 4 is the one that's coming out the end, which is the one I want to use. So I'm going to select that one. Okay, and I'm done. And what you'll notice over here in the system browser is that now the hierarchy is defined. So here's the air handler, and here's the system. So here's the air handler, here's the air handler, here's the air handler system, and then below that in the hierarchy are these two systems. So it looks like we've got everything pretty well put together. So pretty much the next step is to start modeling duct, but before I do that, I'm going to assign a CFM value to all of these diffusers. I'm just going to say there's 250 CFM in each of the diffusers, and you can see that added it up in the system over here. It hasn't added them up yet to the pieces of equipment, and that's because we haven't connected them. So the system is saying that, oh hey, all in sum it's 750 CFM, but there's 0 in the VAV box, and that's because we haven't connected it with duct. So let's connect it with duct. I'm also going to turn it to thin line by pressing TL. Makes it easier to see things. Alright. And we're going to change it to round duct. And something about modeling duct here is that a typical workflow before Revit would be to size the duct with a ductilator, say, and draw the duct the size you want it to be. Now you don't have to do that. Just draw it ballpark. Don't think that much about it because you don't have to. That sounds, I know that sounds bad, but just follow me here. Type FD for flex duct. Connect that guy. Just really ballpark. You don't want it to be crazy. You don't want to be drawing 40-inch duct when you've only got a couple hundred CFM going through a system. But like I said, don't think about it too much. All right, just doing a really rough job here. So now that I've connected these things, you can see that this duct knows that it has 250 CFM in it. And so, you know, if you're thinking about it, there should be something like 750 CFM in here. Well, split that guy. But there's not. And so why is that? Well, what I've gone and done is I've drawn this piece of duct, but it's open on the end here. So Revit doesn't, you know, is air coming out of there? Is it going in? What's going on? So we need to cap that. And we'll do that with a duct fitting. So type in DF. And a round end cap is what you want to use. Go ahead and stick that on the end. And now it knows that it has 750 CFM. Okay, great. That's done for now. Do the same thing over here, and I'm just going to go quickly so as not to bore you. You can pause this or speed it up and go back, but whoa, that was not right. I went a little too fast. Did I get that? Yeah, I think I did. Again, if you want to be fast in Revit, you need to know the keyboard shortcuts. So definitely, if you don't know them, print out a copy of keyboard shortcuts and keep it near you. Okay, so I have those, and now I'm going to connect the ducts between here and here. So just start drawing. Just going to draw a big main, and I'm going to type DF, duct fitting, to put a rectangular cap on the end of it this time. Rectangular end cap. Great. Oh wait, take that back. I'm going to drop it down. So this is up at 20 foot right now, but these VAV boxes are down at 12 foot. So I'm going to drop the duct down to 12 foot. To get on the same level. It'll be easier. duct fitting. Oops. Alright. I'm just gonna pull these guys in here. I'll just go straight in. Not the prettiest duct system I've ever created in my life. Just to be interesting, I'll take this over here. Okay. That's really big. I'm going to bring it down to 24 foot by 12 foot. Just because. Yep, pretty ugly. Alright, but that's fine. So I've just very roughly modeled all the duct. And now, you know, as you select things here, you can look over here and you can say, oh, okay, 750 CFM. Also, Revit is calculating the pressure drop. So the pressure drop in this particular section of duct is 0.04 inches of water gauge. That's because it's at 0.27 inches per 100 foot, which is a lot. That means that that particular piece of duct is really undersized. So, you know, just in this view right here, you could go around clicking on things and looking in the properties and saying, oh, it's undersized, it's oversized. But that's not really the best way to do it. Revit has some view settings that you can set up views so that you can visually see what's going on with different factors. So I've set up a view over here called flow analysis, and I'm going to hop into that, and it looks like my view range is a little too low, so I'm going to jack that up to 40 foot. Cool. So what's going on here is that I've got a color legend that's filling the ducts with colors that represent what the friction sort of sizing factor is for each length of duct. So in terms of inches of water gauge per 100 foot. So at Integral Group, our design principle for sizing duct, just straight out the bat, without any other considerations, is somewhere in the neighborhood of 0.05 inches water gauge per 100 foot. That changes based on situation, but, you know, very first stab, a rough first guess, that's what we do. So looking at, okay, so green is sort of the good zone, and then, you know, yellow and red is higher pressure drop, and purple and blue is very low pressure drop. So you can see here right away, you just look at this and you get a good visual indication of what's going on. These are undersized, these are oversized, this is probably good, you know, this is 0.0499, you know, that's perfect. Right, so you have a good idea of what's going on, and it's very easy to just come in here. You don't even have to think about it or use a ductulator, just say, oh, this is undersized, so you select it, and you know, you bump it up 14 inches. How's that? Oh, green, perfect, good, I'm done. This one, same thing. Let's select this branch, deselect the air terminal. So this one's oversized, so 10 inches? Purple, still a little undersized. How about 8 inches? Okay, so that's oversized. So I'm going to go back up to 10 inches, because I don't know what 9 inches is. Okay, so that's fine. That's 0.037. Whatever, not a big deal. So you can go through like that. There's also a tool in Revit to size everything for you, really. So select everything, filter out the air terminals and mechanical equipment, so you just have ducts, fittings, and flex ducts selected. And so the system inspector is cool. We'll check that out in a second, but click this button, duct pipe sizing, and you can ask it to size the duct automatically for you based on a criteria. Now, if you want it to be velocity, equal friction, static regain, whatever, you know. So I'm just going to select friction, 0.055 inches of water gauge, and I'm going to tell it to go. It thinks about it, and it sizes things. Now, one thing you'll notice, this whole, the color fill region, in 2013, this is a new feature it splits at whenever you tap into it, so that it shows you, over here the flow is I split this earlier. I'm just going to delete that guy so you can actually see. So this is one piece of duct, but the color fill is filling in based on what's happening. So here it's actually 500 CFM, and here it's 750 CFM. In previous versions of Revit, it wouldn't tell you that information. This whole thing would either be grayed, it wouldn't know what to do, or it would just be one solid color, which was sort of confusing. But when we went to size it, it's one bit of duct, so we can only assign one size to this. So we can use the, I call it the slice tool, but it's not slice, it's, oops. It's something else. Well, I call it slice because the keyboard shortcut is SL. So type in SL and just give a slice right here. Sure, right there. So that's not changing a whole lot, but what that is doing is creating individual sections of ducts. So now that we've done that, let's go through the duct sizing exercise. Again, filtered out, so the air terminals and mechanical equipment is not selected. And then, where was that button? Oh, I did it again. Here we go. Duct pipe sizing, friction 0.055, sizing failed, flow for section is 0. Oh, well, okay, so it failed to size these pieces, which actually makes sense, so I'll just set these to 10. But you see what it did here is it broke these down, it made these progressively smaller, which is what you would naturally do if you're sizing to this criteria. So okay, so we've sized everything, and that is pretty much it. We've just put everything together, and I was talking a lot. We took, 15 minutes to do that, but when you get the flow of it, it goes very quickly. It does not take very much longer than the old method of just rapidly throwing things together. So, yeah, that's about it. Go forth and make intelligent models. Thanks. Hope you liked it.